Hi pal, Tony Lockwood here. We're in Cleveland, Ohio, on the case at CAASE 18. And Digital Engineering and Nathan's are the co-sponsors of this show. I have an intelligent person here who's wasting his time speaking with me, and I will just say, please introduce yourself, your name, title, company you work for, and tell us what your company does.
Okay, well, my name is Tim Hunter. I'm the president and founder of Wolfstar Technologies. And Wolfstar Technologies has got their flagship product is a product we call TrueLoad. So TrueLoad basically will take an FEA model and your physical part, and together with some strain measurements, we'll basically turn your components into load measuring devices. So we're giving you the ability to measure loads on just about anything, and then you can use those loads then in your simulation analysis to reproduce anything you've seen in the field.
That's pretty handy. Now, that gets you into all sorts. But you also have a few other products here that complement it. True QSE and True LDE.
Yes.
Get in here, and
so True QSE stands for quasi-static events, and so what we're doing with TrueLoad is we're creating time histories of loading that reproduce the loading that you see in the operation of your product. And then what True QSE does is it takes those time histories of loads now, and then will basically play back those time histories of loads and recreate the full stress fields and strain fields on your part and create operating deflection shapes from those loads. So True QSE basically allows you to post-process the results of the loads you've just measured. Okay?
Very good.
And when we sell TrueLoad, you get True QSE automatically because it's such a big part of what happens.
Okay, very good.
And the second tool, True LDE, that stands for linear dynamic events, and that's got absolutely nothing to do with testing. Okay,
nothing at all.
Nothing at all to do with.
Yeah.
So basically, it's an intelligent post processor for linear dynamic solutions. So doing star modal dynamic, doing steady state frequency domain solutions or PSD domain solutions. It basically is a post-processor designed for the analyst who's dealing with those types of solutions. So it's a very specialized niche post-processor for those types of solutions.
Now that raises questions of horsepower these days is going through a metamorphosis.
Right.
You know, not just from your workstation on up to the HPC and stuff like that. Now, that must mean good things for you guys, right? Because you're crunching some numbers here.
Yeah, we are. What surprising with our products is that the horsepower required to run our products is at relatively low. We're extracting key pieces of information from the databases, and we're working on a small subset of your databases. Now, when we create the operating deflection shapes and things, well, there's some crunching going on.
Right.
But the core capability for getting at the forces is actually a relatively small amount of number crunching that goes through to do that.
Yeah, do you have like an average time? Do it take some?
Well,
every project's different, so that's not a fair question. But
small projects to calculate these loads can take seconds.
Yeah.
And very large projects, it could be 10, 15 minutes.
Really?
So we're not talking hours and days of solves. We're talking go get a cup of coffee and come back.
Yeah.
Right. Okay.
That's pretty good. Yeah. Now, I'm sure you have a feedback loop with your users, what are they saying the challenges they have that they need you to come up with the feature, the toolkit, whatever?
Yeah. So the biggest challenges my users have is we rely, exclusively on strain data information. So really on their end is data collection capability. So if they want to go find 25 loads on a structure, well, they're going to need to lay 50 strain gauges, and sometimes they don't have enough data collection capability. So that's usually kind of the budgeting end for them. And then when they're asking for features, some of the features we've been asked for, and which will be implemented relatively shortly, is they want to put strain gauges in hot spots and have us take a look at those strains in hot spots as well.
Right.
And so we're putting that gauge of interest capability together in the software. So that's a new thing.
Yeah,
so,
with the whole e-mobility and all the Internet of Things.
well,
you know, I saw an interesting application that involved the strain gauges and whatnot.
Right.
Internet of Things and
yeah.
all that.
Well,
you know.
so we've got. There's a capability with our software, with our technology, is basically we're basically giving the structure the ability to sense loads. Okay, so we're basically, you say where you want to sense loads, and we can sense loads. Okay, and then we're basically you can create strain gauges, and we extract this correlation matrix. Well, all this stuff is relatively compact. So you could actually, in the Internet of Things, as you brought that up, the whole idea of the Internet of Things is that as a producer of product, you could actually install these strain gauges in your end user product.
Right.
You could burn this little matrix I'm extracting onto a chip on there, and we could do some very simple mathematics. And as a producer of product, you could give your users real-time feedback on the load on their product as they're using it. Okay, so when you think of the Internet of Things, so now you've got this real-time feedback on the product, and then if you then want to tie that into a network, and you could do some remote monitoring and do all these other things, there's some crazy things we could do. Okay, these are some extensions of our basic capability that we could go to. Okay, we've had customers ask us about it. We haven't had the opportunity yet to do it yet.
Yeah,
I mean, we're talking.
That sounds pretty cool.
We're talking to companies who make basically the crushing equipment for coal mines and rock mines and down in South Africa, and they want to instrument their equipment, and so they can monitor all these things remotely, and they can tell when the parts are going to break before they break, because if you think of these rock crushers. Being down a day, that's tens of millions of dollars, right? So we could tell them ahead of time, hey, it looks like you're going to come up to end of life on this part, So these are opportunities that are out there. We haven't done it yet, but we're in lots of conversations.
That puts you all into that predictive analytics and all that stuff.
It's kind of crazy stuff,
Yeah, it is crazy stuff, especially when they're telling you this is a one-off machine that we had to build down there. So we want to know. Very good. Are you involved with education, training, in the universities, things like that?
We've got several copies of our software out in universities, and basically we give it away for almost nothing or for free. Basically we want to get it in as many hands and get students used to it. So
because one day there'll be middle managers.
They're going to be working somewhere eventually, right? So we want them to use it.
Very good.
Yeah.
Well, great stuff. Now, why don't you give us your web address, so people can go look it up.
So our website is www.wolfstartech.com.
Okay, very good. And I'll have that address available for you. Just go to the DE Editor's mail drop, on the DE site. Drop us a line, and I'll send it off to you. In the meantime, thank you so much.
Great, thank you so much.
That was great fun.
Great, thank you so much.
Thanks, pal. Thanks for watching.